Hello everyone, my name is Keshvi Santuki and today I am going to discuss about comparison of all types of AM, that is amplitude modulation. In amplitude modulation, what do we do is very simple. We change the amplitude of high frequency carrier according to the message signal. The message signal contains information like voice or music, and the carrier helps in transmitting it over a longer distances. So AM is analog to analog modulation technique, and it is one of the oldest and most important modulation method we can say. So primarily we are focusing on the basic types of the AM modulation techniques, which are standard modulation. It means that conventional AM, DSBSC, which is double sideband suppressed carrier, SSB is single sideband, and V is VSB, that is vestigial sideband. Each type has its own advantages and disadvantages, which we all know. Standard AM. First, let's understand standard AM. In standard AM, we transmit three components, that is the carrier, the upper sideband, and the lower sideband. So everything is sent. Because of this, the required bandwidth is twice the message bandwidth, that is of 2 TB. The main advantages of standard AM and is its simplicity, that is, it is very simple. Both transmitter and receiver are simple, which is why it is widely used in AM radio broadcasting. Conventional AM, that is DSB-FC. Conventional AM is also called DSB-FC, which means a double sideband full carrier. Here we transmit full carrier, upper sideband, and lower sideband. The problem is that the courier carries no information but still consumes a lot of power. So the power efficiency is very low, but the receiver is very simple because we can use envelope detection and no carrier recovery is required. That is why it is still used in broadcasting. SSB, which is single sideband. In single sideband modulation, we transmit only one sideband, either upper or a lower. The carrier is usually suppressed because only one sideband is sent. So the bandwidth will be reduced, power efficiency will be higher. However, the receiver become complex because accurate carrier recovery and filtering are required for this. SSB is used where bandwidth and power saving are very important, such as a long distance communication where it can be helpful. Next is DSBSC, which is double sideband suppressed carrier. In this method, upper sideband is transmitted, lower sideband is transmitted, and the carrier is completely suppressed. Since the carrier is removed, power efficiency becomes better than the standard AM. But the receiver cannot be envelope detection, means it can not use envelope detection. It needs synchronous detection, which makes the receiver more complex. Bandwidth requirement is still of 2B. DSCSC DSBSC is used in systems where the power efficiency matters more than simplicity. Next is vestigial sideband modulation, which is VSB. In vestigial sideband modulation, one complete sideband is transmitted. A small part of the other sideband is also transmitted. This is done because sometimes it is difficult to remove one sideband completely. So VSB offers a balance between bandwidth and efficiency, and the receiver's simplicity. That's why we are using VSB. Bandwidth is slightly more than B but less than 2B. VSB is mainly used for television video and transmission. For the transmission, it is mainly used, which is vestigial sideband modulation. Let's see the key difference between AM versus DSBSC. In AM, carrier is transmitted, and in DSBSC, carrier is suppressed. AM has low power frequency, while DSBSC has better efficiency. AM receiver is simple, while DSBSC receiver is complex. AM is used for broadcasting, while DSBSC is used for point-to-point communication. AM and DSB modulators. Now we can understand that conceptually that in standard AM modulator the message is multiplied with the carrier and the DSC offset is added so the carrier is always present. In DSBSC modulator we use a product modulator which multiplies message and carrier directly, so the carrier gets suppressed automatically. So this is the comparative overview of the DSBFC, DSBSC, SSB and VSB. Like uh, it will compare carrier, sidebands, bandwidth and power efficiency and receiver. This is the visualizing of the AM and DSB modulator as I have already told about this topic. This is the comparative signal spectra. In standard AM, we clearly see a strong carrier in the center with two sidebands. And in DSBSC spectrum, the carrier is missing and only sidebands are present. This clearly shows why DSBSC saves power. So, in conclusion, I can say that if simplicity matters, use conventional AM. If power saving matters, then we can use DSBSC. If both bandwidth and power must be saved, then use SSB. If the signal is wideband like video, we have to use VSB. There is no single best method we can say. It depends on the application for what purpose we are using it. So, amplitude modulation has different types to manage: power, bandwidth, and complexity. Understanding their comparison is very important. So, I have taken the old reference from the Forozen book only. So, if you want to know more regarding this topic, you can refer this book. Thank you for listening.